So thank you so much again for being here this morning. As you might be aware, DIST, my department, is a so-called excellence department in Italy. We won a national competition. Well, we were among the many winners of a national competition 4 years ago. And we were supposed to present a research program. And our idea in 2017 was to assemble a quite diverse group of initiatives under the umbrella of Sustainable Development Goal number 11. You are certainly acquainted with the existence of the UN 2030 Sustainable Development Goals. Number 11 out of 17 is titled Sustainable Cities and Communities. And the overall goal is to make cities and human settlements inclusive, safe, resilient, and sustainable. And then you have a number of sub-targets inside each of the goals. And target 11C is to support least developed countries in building sustainable and resilient buildings utilizing local materials. While I completely agree on the idea of using local and sustainable materials in least developed countries, nevertheless, I think that in all countries, local and natural materials should be used. And this is why we have dedicated so much research and teaching activity to this point. In fact, natural materials have excellent properties. They are in many cases renewable or abundant on Earth and require little processing to be used in the construction. Then you might be aware of the fact that I have dedicated a book to the concept of vegetarian architecture. I won't, of course, explain here what I mean when I speak about vegetarian architecture. It is, of course, a metaphor. But the basic point is that, in my opinion, ecologically oriented agriculture and nutrition science appear to be more rooted in reality than architecture. And therefore, I think there is a lot to learn from this concept. Just in front of me, I'm speaking at Lingotto former factory. There is a place called Italy, and this is a kind of supermarket where good food is sold. There is a fashion nowadays for good foods in Europe and in Italy in particular. So it is relatively interesting in my view to understand what is good food. Yeah, of course, good food it tastes good. You can perceive it with your senses, but at the same time, a real comprehension of good food should include the fact that it nourishes, it protects your health, and even heals you. It does not poison those who eat it, or those who process it, or in general the environment. And it relates significantly to natural cycles, to the land, and to those who cultivate it. So it is part of the landscape, of cultural landscape formation. So we might learn something, I think, from such a wide comprehension of what good food is. Essentially, my definition of vegetarian architecture encompasses building with natural, renewable, locally available construction materials, free of toxic chemicals, and as little processed as possible. The minimization of exotic high-tech components, and giving preference to labor-intensive, small-scale production processes, simple constructional technologies, and passive solar design. So my point is that we should acquire knowledge about and make full use of the properties of available materials. The good architect, the good builder knows how to take advantage of what is locally available, and this is one of the reasons why we appreciate and admire so much vernacular architecture. Notwithstanding its long history, natural construction is still at a pioneering stage, because in spite of admiration of vernacular architecture, this is perceived as something belonging to the past, something backward. So today, it is quite a problem to obtain building permits, in spite of the fact that natural materials, which were in use for centuries, are now considered as very dangerous, and there is much more faith in synthetic materials that are likely to degrade in a very short time. Now, it must be understood that industrial substitute materials have usually been developed to reduce labor and construction costs, and not so much to increase the quality or security of buildings. So their widespread usage is more the consequence of investment in money and effort spent to deal with these problems than their superior performance. I think that the basis of much prejudice against natural, renewable, and ecological materials is that it was assumed for many years that hygroscopic materials are bad for the buildings and would rot in a very short time. This is the opinion of Tom Woolley, of course, who dedicated so much effort during his research and professional life to the development of a different attitude towards these materials. It is a common experience that natural materials are assumed to be more expensive, less durable, difficult to build with, lacking approvals and certification, hard to obtain, lacking credible environmental and health aspects. And some of these assumptions are actually true or partially true, but this is not always the fault of the materials themselves. It is usually the problem of the socio-economical system around these materials. In fact, the slightly higher costs associated with building with natural materials is the result of a tax system or a subsidies system which encourages the use of fossil energy rather than human power. Anna Heringer said in an interview a very interesting thing that I like to quote here. She said, "I think that it is not the missing technologies that prevent us from building sustainably. It is not the missing consciousness either. It is the fear of vulnerability and transience. So we want buildings which are indefinitely durable, perhaps even an excess performance of durability is included there. So the industrial paradigm calls for a high level of uniformity and predictability in building components that evidently those made of natural material cannot offer. But there is a problem with assessments, with software. So just a few parameters are considered, and in the light of these parameters, high-tech counterparts score very well, but we forget about looking at the whole picture. Students who are here might recall last week reference to David Eisenberg picture with a certain number of performances included in regulations and a number of other performances usually not included. This chart is from Ashby's book. And of course, you can see that if you consider materials, and here you have all materials, natural and non-natural together, of course, the strength can be a bit low, but at the same time, the embodied energy per cubic meter is also very, very low. So one just needs to learn how to design accordingly. And anyway, there are natural materials such as bamboo or some timbers, which are also scoring very well in terms of strength. And the same here in this chart. This is quite interesting because there are 3 parameters included here: density, yield strength, and embodied energy. And you see that by far the best material is bamboo, and then you have timber as well. Of course, being in this logarithmic scale chart, the lower you are in the chart, the better. Acquiring the ability to design a building using simple technologies based on good craftsmanship and careful selection of local and natural material can be a task, as does obtaining a building permit. These materials are often not covered by standards or environmental assessment software. And this is also why it is so difficult to make use of them. But nevertheless, it must be admitted that not much is actually known about natural materials. A detailed and scientific understanding of their properties and characteristics should be developed, also relying on experimental buildings and field study of traditional buildings. And these are among the reasons why I treasure so much the contributions today of Professor Toki and of architect Volhard, because they have developed a deep understanding of some materials and have tested scientifically the properties of these materials, and at the same time have been using these materials in real buildings which work. So it's not an ideological stance. It is a very practical knowledge that has been developed and tested on many years. My regret here is that scientists and engineers look for ways to improve natural materials so they can function as predictably as industrial materials. I think it is a presumption to improve nature. We should accept it and see how to deal with what is available. Almost no one advocates for leaving natural materials as they are and for deepening our understanding so that we make the best possible use of them. Preservatives and other chemicals in building materials encourage residents to behave irresponsibly and architects to make bad design choices. And there is also a health problem connected with the use of chemicals and preservatives in foodstuff, as well as in the materials we use in our buildings, in our homes. Typically, the mainstream medical view downplays the significance of environmental causes, raising doubts about environmental improvements because of the cost, and instead they prefer drug treatments. While, of course, the first step would be rather to avoid contamination. But we have been taught to live with contamination, to tolerate it, to accept pollution as a part of progress, of a part of our daily life. It must be very clearly stated that every petrochemical product is toxic. It is just a matter of extent, how much, either to people or to the environment or both. It is also very difficult to recycle materials, even metals, if chemicals are involved. There is another point which is very weak in our understanding of the risks associated to chemicals, because usually it is not one single element which is dangerous. The problem, more generally, is caused by a constant background of a poisonous cocktail of carcinogenic substances which are present in our environment, both outdoor and indoor. At present, laws do not require manufacturers to declare what are their building products made of. If you buy foodstuff, there must be a label saying exactly what's in there. But this is not required for building materials. And of course, manufacturers are not required to declare how much energy was consumed in the production, how much pollution was created, and which kind of pollution during the manufacturing process. And as a consequence, choices are less informed and often made on the basis of habit and above all, on the basis of price. We tend to buy what is cheaper. Nowadays in Italy, the state is paying for the thermal retrofit of buildings, and this is why we have so many building sites everywhere. But what is used to retrofit these buildings? Of course, it is expanded or extruded polystyrene. I think that Peter Harper's low carbon materials plus industrial vitamins is a very interesting concept, which epitomizes a realistic, balanced position. Because you see, bluntly, modern projects can be built with a majority of little transformed natural materials whose environmental impact is very limited, plus a few highly manufactured products which allow to obtain a few irreplaceable performances which cannot be reached otherwise. For instance, today's buildings reach very high performance, largely thanks to technologically advanced windows. This is a chart by Pat Borer showing how the evolution of architecture went through several stages from pre-industrial, where of course no industrial materials were available, and then we got to a stage which might be called mature industrial, where traditional materials are used just for veneering, just for decoration, or a very shallow layer to give some sense of naturality, maybe to a flooring or to a facade. But now it might be possible, it is possible to build the bulk of the building with low carbon materials. And modern materials can be used just to obtain special performances. So I'm going to conclude with this very optimistic hope for the future. Preference should be accorded to materials and products derived from renewable and eco-compatible biological resources, or from abundant and non-harmful resources. And this should be the rule, not the exception. As it happens with food, organic food is now, well, quite fashionable, but it is still a market niche. I think this should be the rule, not the exception, or the specialty you can afford from time to time. So let us start from the basics and see how far it takes us. Let's design the fabric first for comfort, and then add the minimum servicing which is required by contemporary lifestyle expectations and standards. We can give preference to biological materials, stone and earth, and then see what needs to be added to this bulk. This is, for instance, Björn Berger's approach when he wrote, it is now 30 years or slightly less than 30 years, this important book about the ecology of building materials. The question at the basis of his research was, can raw materials from non-renewable sources or also from renewable sources be replaced by raw materials from plentiful of or renewable sources, which are much less impactful on the environment. are there environmentally friendly alternatives which can be substituted for harmful chemical substances? And I add one more. Are behavior, both as users and as designers of building, change according to these principles? I strongly believe the answer is yes. And I'm certain that both Professor Toki and architect Volhard share my opinion. And this is why I'm very happy now to leave the floor to Professor Toki.
おはようございます。トキひろかずです。今日は興味深いセミナーにお誘いいただきましてありがとうございます。今日は私と、ヴィンセント・セバスチャン2人で、プレゼンテーションさせていただきます。よろしくお願いします。
So, thank you for inviting us into this seminar, and thank you for the very, very interesting opening speech. And today we will be presenting with me, Vincent, as the translator today.
はい。では、今日は、竹建築の魅力と可能性というタイトルでお話しします。
So to start off, our presentations is all about the beauty and possibility of bamboo. So please enjoy.
私たちの研究室は、ものづくり、人づくり、未来づくりということをコンセプトに、ものづくりを通じて、建築と人の未来を考えると、そういう活動をしています。
The core of our activity is to create is to live. We aim to create the synergy between architecture and people so that we can create the better future. And to do that, from design and implementation, we are doing it all by ourselves.
自分たちで、設計して、ただ設計するだけではなくて、それを実際に自分たちで作って、出来上がった建築空間を人々と分かち合うと。それを通じて、ものづくりとは何かということを考えています。
So we built the design that we think ourselves, emphasizing in three aspects of creative endeavor that are design, the people, and how we will impact the future. So while on the same time relating education, implementation, and research.
それで、研究と教育と実践を結びつけながら、共に学び、共に成長すると。こういうことを目的に活動しています。
So the core of this, our activities is how we can grow together by doing the architecture.
専門は、構造学ですので、いろいろな材料を扱っていますが、今日は竹に関してお話しします。
So while we specialize in structural design, and there are a lot of materials that we take into our projects, but we are going to give the bamboo the spotlight today.
はい。はい。では、竹に関する研究を始めたきっかけは、2つの学生による地域活動があります。一つは人に寄り添う活動、もう一つは自然に寄り添う活動ですが、今日は左側の人に寄り添う活動を中心にお話をします。
So today we'd like to introduce you to two of our start of our bamboo story, and as shown on the screen, we have two. One is to embrace the people, and one is to embrace the nature. And today, and for now, we'll present to you about how we embrace the people.
人に寄り添う活動。この活動は、今から10年前、東日本大震災の津波の被災地で、地域の竹1000本を使って学生たちで作った集会所です。
Firstly, this project is called the Bamboo Arc, and it was when the Great East Japan earthquake happened in 2011, 10 years ago. With the students, we built a community center using 1,000 of the local bamboo.
はい、まず最初に、なぜ竹を使ったのか。それは竹しかなかったからです。これはもう被災直後の、地域の様子です。で、そこに住む知人を訪ねたときに、その人がおっしゃったのは、これからもう一度町を作らなきゃいけないけど、焦ることないんだと。自分たちのことよりも、子供や孫たちに胸を張れるような町を作らなきゃいけないんだと。そのためには俺たちは我慢しなきゃいけないんだということをおっしゃられて、それにすごく胸を打たれました。でただ集まって話をする場所もないんだよと聞いたときに、建築をやっている人間として何かしたいというふうに思いました。
So before that all, why use bamboo? The short answer is it was because there was nothing other than bamboo. We had neither money nor material, yet there were a lot of bamboo. It was when Professor Toki talked with one of the local, and he said, we need to rebuild the town, not for you, not for me. And this is how it looked when the earthquake happened. But for our children and for our grandchildren, so that they can see a town where they can be proud of. For that, we must and we need to persevere. But what can we do when we don't even have a place together? So at the time, Professor Toki felt that he had to do something, and as a person, and of course, and as an architect.
ただ、お金もなくて、その頃は、材料も資材も何もないと。で、その中でどうやって作るかと。そういう中でも、この地域にも竹だけは残されていました。で、竹なら手で切れるし、手で運べると。だからその竹を使って、学生たちと一緒に建物を建てようと。そういうふうに考えました。
So still, even so, we had nothing. No money, no people, no tools, and no power. But there were bamboos, a lot of them. So we, the students, with Professor Toki, thought that we should do something with the local bamboo, something that is achievable by the beginners, by us, while making full use of bamboo's characteristics, which is lightweight and very easy to harvest.
それで、どうやって作っていくかと。まず考えなければいけないのは、素人の学生が手で作れること。そのためには、竹という材料の持ち味を生かすこと。それを考えました。
So we started to think for a system where we can bend the bamboo as it is without cutting it to make a space, which is very, very achievable for amateurs like us.
それで、竹の特徴っていうのは曲がりやすい、しなりやすいっていうことですから、それを生かして、竹を切ったり割ったりせずに、長い竹のまま曲げてできる形、それが何かっていうのを考えてきました。
So what we tried to achieve was how can we use the bamboos without cutting it, a long span of bamboo without cutting it, and that was the main questions.
で、それで、あと、自己釣り合いのアーチを作る。それを自組で組み立てる。竹を曲げると戻るので、反力が必要なんですが、普通だったらコンクリートの基礎を作ればいいんですが、それができない。だから、自己釣り合いの形を考えました。つまり、竹でトラスを作って、それに長い竹を結んで曲げると。でこうすれば、自己釣り合いの形ができる。それを、地面の上で組み立てて並べようと。そういうふうに考えました。
So the answer that we got was an arch, a self-subverting arch that is assembled on ground, such as this picture. With bamboo's strong repelling force, normally one would make a concrete foundations, but well, we couldn't do that. So we thought another way to make it self-supporting, which is to make a truss below the bamboo, and then to connect the two fixed pole with ropes in the middle.
これで、地組みで立てたフレームを、立てて放射状に並べて、真ん中に屋根を乗せると。それで建物を作っていこうと考えました。
So with these frames, we can line it into a radial shape like this to support the roofing and finally make a structure of a building. Yes, but okay. So.
で、徐々に高さと、幅を変化した渦巻き状の空間と。このまま並べただけで中に入れないので、アーチの幅と高さを少しずつ徐々に変えながら並べていきました。そうすることで、この終わりのない渦巻き状の空間が、できました。
So, in order to create an opening so that the people can get into, the heights and the width of the frames are made to be gradually changing. So the resulting shape is like this.
形の根拠。これが出来上がった建物で、海沿いにあるんで、渦巻き貝のイメージですかってよく聞かれるんですが、全くそんなことはなくて、この建物の根拠は、素人の学生が手で作れること。ただそれだけでできた形です。
So the reason for the shape, well, we were often asked that, is it because it's near the sea that you made it like a shellfish? But no, actually it was just a coincidence. It is like that because this is the most logical shape for us, the students, to make. So that's all.
それで、さあ作ろうと。大きな建築を作ることになるので、まず現地の竹を大学に持ち帰って、強度を調べます。それと、どういう形で曲がるかということを解析で、確認した後、実際に実験をして、その形、それとどこまで曲げると折れるか、それを、実験と解析を並行しながら検討していきました。
Still, we didn't know at all about the material, so we need to understand it more. So we brought back plenty of them to our campus and did an experiments like this. Mostly the mechanical properties and how much can a full-length pole can bamboo bend, and from there.
で自分たちで作るので、たくさんスタディすることがありました。それをスケッチで考えて、模型を作って、で実際に実物を作って確認をして、また実験をすると。でこういうことを繰り返して、スタディを進めていきました。
So from that, we started the design, and we did a lot of mock-ups like this, and of course, lots of all-nighters were spent. And then we finally started the scheduling for the project.
でそれで、建築を建てるには仮設でも行政の許可が必要です。日本では竹の建築っていうのは法律では認められていないんですが、この建物は特別に許可を得て、日本で唯一の竹で許可を得た建築です。
So permit, it's a big problem at that time because in Japan, bamboo even now hasn't been recognized as a structural material. So there had been few to non-bamboo structures in Japan until the time Bamboo Arch passed the application. although only as a temporary architecture, bamboo arch, as far as we know, is the first full bamboo building here in Japan.
で、許可も得て、いざ施工です。施工には、全国から40人ぐらいの学生が集まってくれて、共同作業を始めます。
So after the permission was confirmed, there were around 40 students from all over Japan gathered to construct the arch.
で、被災地で生活する場所、住む場所もなかったんですが、被災した人がうちの裏庭使ってくれよと言って、そこでキャンプを張らせてもらって、キャンプ生活をしました。
And but one problem at that time was that there were nowhere left for us to stay. But thankfully, we were offered to use the backyard of a certain local, so we set up a camp over there.
作業はまず瓦礫を片付けて、亡くなった方にお参りをして、それから作業を始めます。
The construction started from cleaning the rubbles and then praying for the people who regretfully lost their lives in the disaster.
で作業はすべて手作業でした。竹を切るのももちろん手作業。でそれを運んできて敷地に持ち上げるんですが、道路が津波で流されているので車が通れない。だからそこに上げるのも手作業。
So the process is all by hand, and from harvesting to transporting the bamboo. And well, since the roads were washed away by the tsunami, so trucks could only get us so far. So we had to bring them all by hand.
でコンクリートの基礎が作れないので、建物のウエイト、それもすべて土を詰めて土のうで、これ16トンの土のう詰め、これも手作業でした。
And since we couldn't build concrete foundations, we used backed soils like this, and a total of 16 tons of them were used. And of course, all of these were made by hand.
でもちろんフレームを組み立てるのも手作業。ロープを使って、作っていきます。で最初はなかなかはかどらなかったんですが、もう夜明けからやりますと言ってくれて、日の出る前の暗いうちから学生が、頑張ってくれました。
And of course, the frames and the joinery were all done by hand by us. And there were a lot of trials and errors. So a lot of night operations and early mornings operations.
被災地で電気も何もないので、懐中電灯の明かりだけで作業をしています。
So like this, we use lightings to do the buildings, to do the frames.
それでようやくできて、これを並べれば建物ができると。そこまで来たんですが、そこにやってきたのが台風が近づいてきました。それで、雨や風が強く降る中、学生たちは頑張ってくれました。
So in the process, a typhoon came, and even so, the students didn't stop working. And like this, it was a very, very hard work, to be honest.
それでようやくフレームが立ったというときに、実はさっきの台風が直撃されました。でこれがその時の様子で、朝起きてみると、すべてなぎ倒されていた。でこの時は目の前が真っ暗になりましたけど、よく見れば倒れてはいるけど折れちゃいないと。だからこれを立てれば元に戻ると。みんなで頑張ろうというふうにもう一度、作戦会議をしました。
So when the frames had been placed, the typhoon finally hit the area and it was getting dangerous. So we went back to the camp. At the site the next day, we found out that the frames had been toppled, like the last picture. And it was hopeless to say the least. But when we look at the structure, there were actually no broken members. And so we can rebuild them. And then we held an emergency meeting then like this, only 5 days until the deadline.
それで残された時間で何ができるか。で、目標が決まればみんなまたやる気を出し、元気を出して、頑張ってくれました。
And now it's time to try again. Strange enough, actually we were more motivated than ever.
それで、建物を建て直して、屋根を真ん中に乗せて、フレームが完成しました。
And thankfully, it was time to place the roofing, completing the structure.
で日本では建物が形が完成したときに上棟式っていうセレモニーをして、お餅をまいてみんなで建物の安全を祈ってくれると、そういうセレモニーがあります。でこれはこの地震後、津波後、この地域での初めてのお餅まきで多くの人が集まってくれました。
In Japan, it is common to hold a ceremony when a structure is completed. And after the area was hit by the disaster, it was the first festival in the area. And for the people who came, we give mochi to them, and we pray for the bamboo's arc completion.
で、お年寄りもおまわりさんも多くの人が集まってくれて、建物の安全を祈ってくれました。
And so like this, we did a very fun festival at that time.
でそれで建物ができたときに、何もお礼ができないけども、せめてお礼をしたいと言ってくれて、自分たちの舞を見てほしいと。で地域に伝わる伝統芸能を待って、学生たちに感謝の気持ちを示してくれました。
And when the art was finally completed, the local residents wanted us to see their traditional dance as a proof of thanks. So we held a proper festival this time.
で竹は丸くて自然なので、早速子どもたちも大人気で学校の遊び場になっていました。
And then the ark became a children's play spot. Nest, we should say. It must be the bamboo's natural yet round shape that piqued their interest.
それで、建物ができた。これからどうやってこの建物を維持していこうかっていうことを、地域の人と話してたときに、横で聞いていた学生が、竹友って会を作りましょうよと言ってくれました。
Now, the next big problem is how to maintain the ark. One student had an idea to create an association called Taketomo, which means with bamboo.
でこれが、初代の会長ですが、彼女が言ってくれた言葉は今でも忘れません。それは、一人一人の力は小さくても、みんなの力が集まれば大きな力になると。それを感じました。だから、これからは小さな力を集めて、この建物を守っていきたいんですと。そんなふうに言ってくれました。
And a word from her, even if each of our strength is limited, our true strength is in our unity, she said. And that was what Professor Toki and her and us felt through this workshop. And we hope to protect this ark through that strength.
で、それから7年半 この建物は維持しましたけれども、毎週さっきの虎舞の練習を地域の人がしたり、あと、その竹友の学生たちと、毎年2回、地域を訪れて、手作りのお祭り、交流を深めました。
And the art continued to stand for 7.5 years, and every year we held two festivals, and as the local communities in the local community center, where we also interact with the locals.
で、自然の竹をそのまま使っているのでやっぱり傷みやすいんですけれども、まず行ったら傷んでいるところを直して、建物を蘇らせて、それから、子どもたちと触れ合うと、こういう活動をしていました。
So the bamboo used were all natural, and of course it degraded fast, it rots. So we go to the ark every year to replace the broken parts. And every time we go there, we hold a festival. And so we do the maintenance, and while on the same time connect with the local communities, playing with the local children and all that.
それで、7年半、建物、存続しましたけれども、新しい公民館もできて、一応約5面ということで、一昨年に解体を、しました。でこれが解体の日ですけれども、また、虎舞の人たちが集まって、最後の別れを惜しんでくれました。
And after that, a lot of things had happened, and a new community center was planned to be built. So finally, the bamboo ark can rest, and so we plan to dismantle it. That time, the local gathered to do their last dance for us.
それで、今まではここで起こった出来事を振り返ろうということで、1日限りの展覧会をここでやりました。
And we held a memorial exhibition just for a day, just to show what had happened in the past.
で、多くの卒業生たちも集まってくれて、同窓会のように、みんなで楽しみました。
Just like this, we did a small kind of event.
できたときこんな小さだった子供もすっかり大きくなって、8年という時の流れを感じました。
And the children who were so small when it all started had grown up so much, and so it was very, very hard to say it into words how moving it was.
で最後に、ライトアップをして、綺麗な姿を見せてもらって、で、解体です。で解体は、建てた時と逆の順番で、屋根から外して、学生たちの手で丁寧に解体されていきました。
And then the dismantle process began. And the process itself was in the opposite order of the constructions, from the roof to the deck, and then the flooring like this.
で、解体した竹は7年半経った、竹の強度などを調べるために研究室に持ち帰って、でそれ以外のものはチップにして土に戻しました。
So for the parts of the bamboo ark itself, we brought a few of them back to the campus for our research, and the rest we returned it to the ground, to the site like this. We ground them up to chips and make them as a fertilizer.
で学生たちの手で築かれた建物は、学生たちの手でまた土に戻った。でここにまた花が咲いて、みんなが集まる場所になるように祈りながら、土に戻しました。
So we who built the structure were the one who returned it to the earth. And we hope that at that place, there will be another place together in the future.
そういう建物です。で、もう一つは、自然に寄り添う活動と。で、これは放置された竹林を地域の人と学生とで整備して、その竹を使って自然を感じる豊かな場所に蘇らせたと。そういうプロジェクトですけれども、今日はちょっと時間の関係でこの話は省略して、また機会があればお話したいと思います。
The next project is our activity to revitalize the bamboo groves, which has been a big environmental problem in Japan. And it is our endeavor to embrace the nature. And unfortunately, since we have a little time today, we'll make it short and simple this time. Probably the next time. If we have the next time to present it to you, we'll do it again.
でこういう2つの活動を通じて、私も学生たちも、建築とは何かと、気づくことは何かということを体で感じました。
So these projects are a start for the students to experience what architecture means, what it is to build something that grows, that connects.
でこれが、ワークショップに参加した学生が書いてくれた言葉で、これが全てを物語っているんじゃないかなと思います。
And while this is another word from another student, I'll read it. Through connecting to each other, it is the beauty of craftsmanship that I experienced. The smiles of the children playing, enjoying the space within the bamboo's arc. There lies the strength of architecture.
こういう経験を通じて、建築とは何かっていうことを感じるとともに、竹という材料の、にはまだまだすごく魅力と可能性があるなと、そういうふうに感じました。それで、研究開発を、始めました。
Now, through the mentioned projects, we felt a big potential in bamboo to open our society. And our approach to do that is to use bamboo naturally and both engineer.
で、アプローチには2つあって、1つは自然のまま使う、ナチュラルフォームで使うっていうやり方。もう1つは竹という材料の強度特性、それを生かすという2つのアプローチがあります。
So there is two vectors of our activities right now is to use the bamboos as natural as possible, and the second one is to use it in an engineered way that still make a full use of bamboo's characteristics.
で、この自然な竹をそのまま使うというときに、一番最初の課題になるのは、その断面がわからないっていうこと。断面サイズが、太さと肉厚が徐々に変化するので、計算することができない。それが一番最大の課題でした。
So the biggest problem of using natural bamboo is that the section size differs for each unit and each line, making it hard to conduct a structural analysis.
それで、取ってきた竹を2つに割って、径と肉厚を測定していくと。それをやりました。
So we did a full research to find out the rule for how the diameter and thickness varies.
で、日本には妄想竹と真竹っていう2つの、 竹が主流なんですが、それぞれで性質は違うんですが、ある定式化できるということが分かりました。
So in Japan, there is two types of bamboo, which is Moso bamboo and Madake bamboo. That's what we call. And while each type differs for each rules, sure enough, there was a rule for the size change. And with this, one can predict the whole sections of a bamboo by just only knowing the root size. And of course, just what I said, the rule differs for each species.
これが分かれば、根元の径と種類が分かれば、全長にわたって、断面サイズを、推定することができます。次は強度の試験をした結果が、これです。左が根元、上が先端で、断面あたりの強度は上が大きくなるということが分かりました。
So the next one is about the strength, and what we found is pretty interesting enough. Is that what you can see over here is the left part is the roots, and the right part is the upper part of the bamboo. And you can see over here is that the upper part of the bamboos is stronger than the roots part.
それをもう少し調べてみると、竹の断面の中に維管束という繊維があって、それが上に行くほど密になると。だから強度が高いということが分かりました。
And when we brought it to the microscope, we found out that there at the top of the bamboos, the cellular walls is denser than the roots part, and we concluded that it was the reason why the upper part is stronger than the roots.
それで、それを生かして、自然な竹を生かした、フレーム、それの開発をしています。で、一つは、これはレシプロカルっていう組み方で、木の組み方ではすごく古典的な組み方で、お互いをテコにするっていうやり方です。
So we started to design a structure that can utilize the tensile strength of bamboo. And this is what we thought at first is the reciprocal system structure. And it's a very, very classic one.
これを竹でやれば曲げながら組めるのでより安定すると。でそれを組み合わせてどういう形ができるのかということを考えたり、でこれは
the common one with wood pushes downwards, but with bamboo we can push it upwards with the bending strength. And when the frames are connected, it is possible to create very, very
でこれは長い竹を放射状に回して組んだ後持ち上げると、そういうプッシュアップで作った建物の例です。
So like this space, and which is the next system with which one can use to create a high structure by pushing the member from outside towards the center, and we call this the push-up system.
次のアプローチ、これは2つ目のアプローチ。それは材料の特性を生かすと。で竹っていうのは木の10倍ぐらい、鉄の3分の1という高い引っ張りの強度があります。それを生かして新しい繊細な建築を作りたい。そういうふうに考えました。
So our another approach is to make use of engineered bamboo with that knowing that bamboo has 10 times strength of the wood, it should be possible to create a bigger space with even smaller structure.
その時に問題になるのが、ジョイント接合部で、いくら材が強くても、接合部が弱かったら効果がないと。ということで、ジョイントができるだけシンプルな フレームを考えました。
But even with this potential, with how the steel connection does, we have always done. We can make use of that strength, so it is necessary to rethink how to do the joining.
で、この今映っているのは日本の、障子っていう伝統的なフレームですけども、それは材を半分書いたものをこう組み合わせる。これでできます。で、これだと立体には組めないと。で、そこで半分ずらして組むと、釘も何も使わずにリジットなフレームができると。こういうことを開発しました。
So what is shown on the screen right now is a traditional Japanese door and traditional lattice, and by using 3 identical units that is cut in half depth and assembling it like just Professor Toki shown, one can make this into a 3-way lattice and to create a new structure like this.
で、これだと組んだり外したりできるので、自由自在に移設可能で、長さを変えれば形も変わると。ということで、全国でワークショップをしています。で、これは、庭園で仮設のお茶室を作った例です。
And this system is easy to build, easy to transport, and most important, is easy to dismantle. And we have completed a lot of projects in the past with this structure system.
それをまたばらして、いろんなところで、ワークショップをしています。で、これは、被災地に作ったもので、移動可能な、ロードサイドショップ。これでも、地域の若者に夢と元気を与えようというふうにして考えてやっているプロジェクトです。
And this one project is a roadside shop that we did in a disaster struck area, and we did it by ourselves to give a dream to the local communities.
今の紹介者が木でやったんですけれども、それを竹を使えばもっともっと大きな建築ができるということで今開発をしているところです。
Well, the last project we introduced you was made by wood. It should be possible for bamboo to make an even bigger structure.
で、これは自然の竹ではやりにくいので、加工します。で、どうやって加工するかというと、丸い竹を割って割り竹にして、それを削ぐとこういう平らな板になります。で、これを重ねて、集成材にすると。こういうやり方で作っています。
So what we try to do is to engineer the bamboo, and how we do it is to split the raw bamboo, to plane it, and then stack it up, and just like this.
それを使えば、こんな大きな建築もできるということで開発をしているところです。
And through that system, it should be possible to create a space such as this.
で、これは、自然な丸竹と、この加工の格子の竹、これを組み合わせた例です。
This one project is our idea to combine both the natural and the engineered side of bamboo.
で、これは、この板の状態で重ねてこう開いて、アコーディオンにして開いて作る建築。これはセバスチャンが考えたものです。
So the next one is to make use of the planed member, and that is expanded when pushed and pulled like an accordion. I proposed this one to Professor Toki after looking at a fruit net in this supermarket.
これは、板を曲げて3つ重ねて、それで、それを組み合わせて、ドームを作ろうと。そういうスタディをしている。
And so this One is a further development of the previous ideas, creating a dome with triangle member. The system is the opposite of polar dome, if you know it, where we use a bending rather than compressive.
でこれは、しなりやすいという特徴を生かして、人間に優しい、柔らかい椅子を、竹で作ろうと、そういうふうなことを考えて作った、いわばバネのようにこうしなると、そういう特徴を生かして、作った椅子です。
So we also made a few designs for furnitures using the systems, utilizing the elasticity of bamboo to create chairs that suits itself to the users like a spring.
はい。それで次その材料の特徴を生かして、より可能性を考えた案。これは、コンペの提案で、建築家の坂茂さんとコラボレーションした提案で、日本の大分というところの空港のターミナルビルです。
This one is a proposal that we did with an architecture Ban Shigeru for Oita Airport Terminal. And Oita is famous for its bamboo craftsmanship, so we need a design that is suitable to be its landmark.
で、大分というのは伝統的に竹産業が盛んなところで、そういう町の新しいランドマークを竹で作ろうということで、この建物は高さ40メートルあります。
And the height of this design is around 40 meters, so it's pretty massive.
これが坂茂さんのファーストスケッチ。で竹というのは引っ張りに強いので、引っ張りの力が働くような吊り構造にしようと。でそれを日本の伝統的な竹細工のむつめ編みというやり方で組もうと。そういうふうに考えました。
So as a whole, we try to use a suspended structure to make full use of bamboo's tension. And since the scale is massive, it is necessary to make the structure two-layered, and this is the concept that we used. It is inspired from traditional bamboo knitting called mutsume ami.
ただ、こんな大きいものが編めないので、実際には修正剤を使って組んでいきます。で、厚さ18ミリ、幅300ミリの板を2枚隙間を空けながら重ねて、それぞれを間を通していく。そういうやり方で、組んでいます。
So what we use is an engineered bamboo planks, which sizes 18 millimeters in thickness and 300 millimeters in width as a two-layered system like this.
それで、平たい板を3次元の形に曲げるので、どういう形にすれば曲げたりねじれたりうまくできるか、その曲率を模型と、でスタディしているところです。
So since it's a planar shape that we have to twist and all that, we have to do a lot of mock-ups to find the right shape.
でこれが、実物大のモックアップで、どうやって、人力で曲げれるかというのを確認しているところです。
And this is one of our mock-ups with one by one scale.
で、こうやって準備をしていたんですが、コンペは残念ながら2位に終わって実現、まだしていません。
So we were in the middle of doing the mock-ups for the structures when we got the news that the proposal got only a second place. So unfortunately, it is an unrealized project.
あと、竹建築を使って、ポストコロナの新しい生活スタイルを提案しようということで、これは自分で組んだ竹フレームを、好きなところに持って行って、で、自由に、 自然を感じながら仕事ができる、そういう生活スタイルを提案したもので、これはアドベンチャーワールドという、日本のサファリワールドで一つ建てました。
So what COVID has shown us is that we need to rethink our lifestyle. And through this project, we propose a design for how we work through bamboo. We call this one Ovocation, and it's a working vacation lifestyle where work and leisure becomes one, and you can do both in the same time. The concept is to experience nature firsthand and to harvest, to use, and to make your own space that is transportable. And we built this project in a safari park in Japan.
でこういう活動をしていますが、私たちの活動の究極の目的は、竹の復権と、竹とともに生きる社会を目指してということです。
So we are trying to solve is how to live with bamboo in a river and to revitalize the bamboo growth.
放置された竹林問題というのは日本全国で社会問題になっていますが、究極の解決には、竹を愛して自然を愛して地域を愛する若者が育つこと、それと、もう使われなくなった竹という材料に新たな価値を見出すこと、この2つが大事かというふうに思います。
So what we have to solve is the separation between nature, that is bamboo forest, and the community, and how to solve the lack of value of bamboo that is happening over years.
それで私たちの活動は、学生と地域の人が手を携えて、竹林を整備して、それで、そこを新たな自然を感じる場所にすると。それによって、地域愛、自然愛を持つ若者が育つ。つまり、生きる自然は地域を育むというベクトル。
The first factor of our activities is to revitalize the value that nature has lost while connecting the local with it.
で、もう一つは、竹という材料に新たな価値を生み出して、竹ならではの、新たな建築を作ると。で、それを通じて、竹だからできる新たな生活スタイルを、提案すると。新たな価値が社会を作るというベクトル。
While on the same time, trying to figure out how we can create a new demand for bamboo through research, which is the second factor.
で、自然を愛し、地域を愛す若者が育ち、竹の新たな価値が見出される。それで竹林は復権して、竹と共に生きる社会ができると。こういうコンセプトで活動しています。
And it is through these two factors that we think we can contribute to the society which based on the nature that is bamboo.
私たちには社会を変えるような権力もお金もないんですけれども、こうやって竹っていう材料に親しむ人々が親しんで、新たな価値を考えてくれれば、やがて社会は変わっていくと。そういう思いで小さな活動を続けています。
So while we have no money nor power, it is through these small projects that we hope we can help bamboo to touch the heart of the people and ultimately to better our community and society.
最後、竹っていう材料を、自然な材料を扱って、すごく大事だなと思うのは、信じることだというふうに思いました。で、自然な材料、はい。
And a short final word to use natural material is to believe.
自然な材料ですから、もちろん欠点もあると。ただその力ずくで欠点をなくして均質化しようとすると、持ち味が消えてしまう。だから欠点を強制するよりも、 その欠点をカバーできるようなシステムを考えてやるべきかなと。でそうすれば彼らは持ち味を最大限発揮してくれる。つまり、技術の力で無理やり均質化するんじゃなくて、欠点を許容してカバーするようなシステム。自然な材は自然のままに使ってあげること。それが一番大事だなというふうに感じています。
So to believe is not to force standardization, but to believe in the material to create a system that could embrace its flaw, to use them as it is, natural. And nature is not homogeneous. Nature is duality, good and bad, virtue and flaws. And when you force the material to be what you want, the material loses its virtue. And their weaknesses must be embraced, not to be forced to be disappeared.
最後、信じること、任せること、そうすれば、彼らは最大限のパフォーマンスを発揮してくれて、新たな可能性が広がる。そういうふうに思っています。
And to believe, to entrust, and only then they will show you their greatest strength, and only then they will show you a new way.
で最後、これっていうのは、教育と同じだなというふうに感じています。
And the interesting thing, it's just like education, isn't it?
ありがとうございました。
And thank you for your time and attention.
So thank you so much, Professor Toki. Thank you so much, Vincent, for the translation. I find that your speech has been extremely interesting and touching, because it's really coupling the technical knowledge and the spiritual motivation of doing things. So thank you so much. I will now leave the floor to architect Franz Volhard, who is here in the room. I'm going to call him here to present his speech.
Okay, we'll start. First of all, I have to excuse my English. It's very bad. I speak a little bit better French, but we can only communicate with English here. Okay, I will start. Okay, some words about my person. I'm architect. I was interested in earth building since the 80s of 1980. I started to interest me on earth building. Yeah. And later I wrote a book. It's here if you want to see. And I wrote another book. Oh no, it's not here, but I have some small information about. I participate to write in Germany regulations about earth construction. There are official regulations now, and yes, I want to show you our projects. We built some houses together with my wife. My wife is here, it's Ute Schauer. Our office is called Schauer and Volhard Architects. And we work since nearly 40 years on ecological building, mainly construction of wood and earth. Yeah? And this aspect I want to show you. We built also other projects, not with earth, but this is our favorite point of interest. Yeah, this. If you hear about earth construction, mostly you are confronted with books about earth construction, and what you find in the book shops is always this kind of earth construction. You see Morocco buildings, you see Yemen buildings, 10 stories, massive, solid, load-bearing constructions. But in contrary, in our region, in Northern Europe, we don't find these architectures because we have another climate. We are not in Africa and not in Saudi Arabia, not in Yemen. We are in Northern Europe, and we have rain, and we had cold weather, and we have other conditions. So we have to find other methods to build with natural materials, wood and earth. And so in former times, in the tradition of building with natural materials, wood and earth, is timber frame construction. And you find it in Germany, you find it in France, you find it in Belgium, in Holland, and also in northern countries and Scandinavian countries. A lot of timber frame. I don't know, in Italy it's not so widespread, maybe because Vitruv, the Roman writer about architecture, you know him, he was not very amused about framework, because and he write it's very bad construction because there are many joints and the air comes through the fence, no, the leaks, yeah, and it's cold and it's not very good. And but he is not right. The framework construction or timber frame construction is very widespread, and there are very good old houses in good condition, and this we have to study. Yeah, mostly. Yeah, this is in a town in Germany, this Tübingen, and you don't see that is earth architecture. Yeah? You see some houses, but nobody knows that in earth. All the ceilings, all the walls, internal walls, external walls, also roof surfaces are filled up with earth. Mostly mixture of earth and straw. It's straw clay. That's our word for that. And yeah, the big advantage in our climate to build with a timber frame construction instead of build solid walls in the sky is the site is protected from the rain. Yeah, it's protected against the rain, and you work in dry conditions, and the work is not interrupted by the rain. So this is my structure for the lecture here. I start a little bit with the history. I look back what was the tradition in our region, in our country. Then my first experiences with light earth. It's a light mixture of earth and straw. Then our projects together of our office. Then a chapter, maybe it's difficult to handle with my English, but I hope it works with the pictures. And then a conclusion. Yeah. Very good. Yeah, okay, I start with some pictures of the history. Yeah, building with wood and earth is very old. Here is a nice picture in the foreground. They erect the wooden construction, the timber frame, yes. And here you see somebody, he takes some straw clay here. It's ready mix here in this state, and he fill up the spaces between the between the grid of some stakes and wattles. Yeah, we fill it. You cannot fill the whole space just like that. It must be you must have a structure to hold the soft yeah, here this. Oh, my mouse, you don't see. Like, how can I see my mouse here? My mouse? It's not possible. Here. Okay. I hope it works also with the next. Yeah, still okay. Yeah, the framework construction, it's constructions to save the amount of wood. Yeah, it's before they build, it's more simple. The lock construction, it's massive wood post of another horizontal layers of wood. You just build the ball, and you have the problem that the air will penetrate, and it's cold because of air ventilation. Yeah, so they use from the beginning, I suppose, to tie the fence, the joints, to tie the joints with earth. Yeah, and here this is in an open air museum in Romania, and there you see both the old system and then the sealed system with earth. It's interesting, but later there was not enough wood. You use wood for all purpose, to burn, to make food, and to cook, to make ships, yeah, for the war. And so there were times of wood scarcity of wood, scarcity of wood. You understand? It's very expensive, and so you have to economize the amount of in the building, and so you invent a structure with posts and some horizontal elements, diagonals to stiff it. Yeah, and this is a very old house in Belgium with a very modern looking facade. I think it's very nice house. Also, these parts are nice. Yeah. Okay. And even the Romans, they were in Germany, and during the times Jesus Christ was born, and from this time we have in a museum in Germany there is a wall, this wall, and it's a Roman wall, a Roman half timber construction with straw clay filling and the traditional Roman lime plaster, and then alfresco lime coloring ornamentation. Yeah, it's 2,000 years old and still existing. But normally we see always these kind of houses in our region near Frankfurt. You find often some houses which are not maintained very well, and you see the earth. Before you don't see, it's cladded or plastered. But if a house is not very good maintained, you will see the structure and the construction. It's interesting. You find out there are many variations of the space in the panel, yeah, the structure to hold the straw clay. They are wattles. These are willows of willow, branches of willow, yeah, or hazelnut, or only stakes, vertical stakes or horizontal stakes. All is you can find, you can imagine. You play with the material, and everybody has another idea, and so you find very much variations of construction. This is a wall in one of our projects. We found it's existing internal wall. It's very good quality, very hard, and no very much shrinkage. Yeah, this was in our country. This last year we went to France, to Troyes. It's in the middle of France, and you find these only specialists as me can see. Okay, that's earth construction, because we know that in Troyes. You see in some streets, you see also damaged houses, and you see it's earth. Yeah, in the wooden construction, it's earth, but here you don't see the earth. You see town architecture as everywhere. Yeah, and but I know it's earth because I see all the windows. The window frames are in wood. That's a sign. It's a framework construction. It's not massive stone, brick, masonry. It's made of wood, and the filling, I know if I go in the street beside, the filling is earth. And yeah, mostly the material wood and earth is not showed, not presented for the public. It's hidden behind a plaster, and they wanted to make architecture, classical architecture, and not showing the material. The material earth they didn't want it to show because it's dirty or it's brown, or they decorated their houses and made architecture. And yeah, another example in France. I have also examples in Germany. Here, 6-7 story high in the center of cities. Yeah, you find these big, tall buildings, and nobody speaks about earth. It's town architecture. Yeah? And this is in Rouen, in Normandy. But also in the Normandy, we find a very curious method to close the space between the columns. Yeah? This is this zigzag stakes. Yeah? You find it in this characteristic vertical division, geometrical division of facades. Yeah? And these narrow spaces are the reason for that is you have diagonal small pieces of wood which are just fixed in fence in the posts, yes. And but in Normandy we see also we see very good maintained houses, but also very bad qualities, and now I come like that, and the plaster is falling down, and it's very bad quality, and the reason is there is not enough straw in it. And here I will show a good example of straw clay. It's here in our town, Darmstadt, nearby Frankfurt, and I made some experiment with water, and I can look in the inside of the panel, and there is very much straw. And the straw, the effect of this straw amount is to stabilize the volume of the panel. Yeah, if you have no straw, the panel will shrink. Yeah, because the water goes out. Yeah, it evaporates, and the volume will be smaller. Yeah, by drying. But the straw content will maintain the volume. That's very important for good quality. Also, the straw structure is good for adherence of the plaster, because all these fibers here, they are activated by some scratching the surface, and so the fibers go out, and the lime plaster can very good adhere on the ground. And this is a principle. Also in the lime plaster are fibers, yeah, from cows, yeah? And so both fibers are connected together, and so a good quality of plaster and earth ground, you cannot take the plaster away. And if you have no fibers in the ground, for instance, for rammed earth house, yeah, you have rammed earth, you have only earth, and if you put some lime plaster, it's really very bad, because there are no connections, and so the lime plaster will fall down. And I found here nearby Weilburg a region with rammed earth, old rammed earth houses. They put it first a straw clay plaster on the rammed earth. It sticks on earth, it sticks, but the lime plaster sticks better on this straw clay. Yeah, it's an undercoat plaster if you want. Later I studied also later I studied on to research all these old straw clay panels, and in this very old house, 700 years, I could make research on these 5 panels, and I found very interesting results. I will pick up, I will focus only one aspect, one panel. This is from 1583. I found that the earth is not applicated like that, yeah, as mass, as plaster. It's applicaed by hand, and in big portions they put the straw clay in the panel. Here in this example, in diagonal portions, they make wall like a cop wall. I don't know, you know cop, but it's also earth construction, where you put portions of straw clay of another axis. Yes, okay. And what's also very interesting here, I could resolve the separate the material, the straw and the earth, by water. Yeah, I could do it in water, and I could reuse it, or I can analyze, or no, not analyze. You see the result here. I could take the straw, even the straw and all the branches, the willows in it, and I could analyze or see it. And it's possible it's not possible with concrete. You cannot take the sand out. It's finished. It's a chemical reaction. But here it's bound only by drying, and so you can repeat this process, drying and solving with water every time. Yeah. This is a book which I wrote about this research. Oh yeah. We start with light earth. Can earth be a modern building material? This was my question as I started with to interest me on earth construction. Which construction method is suitable? I will point some aspects about the physical properties. What's about the thermal protection? Thermal, then moisture, fire, sound, then the amount of work to build. All these are aspects. If you want start with earth building, all these aspects are interesting, and load bearing or frame construction, I pointed it. Convertibility, reusability, indoor climate at the end, and non-toxic maybe is also the aspect from the beginning. I want to have good properties, and how can I start? I studied literature, because in the 80s there was nothing. There was no products in earth, no contractors, no craftsmen. And so we have to read books, and I found very much books after the wars in Germany. There is a big literature about earth construction after the wars, because during the war, there was no energy and no building material, and so they were interested on earth building. And I found this method. It's a light earth building, and in this book, and it's very easy. I found it very easy. You put some earth in water, you make a slip, then you pour the slip over the straw, and then you mix it, and you have some cow mist, and this mixture you put in a shuttering, and this method seems me more simple and more easy than a straw clay. The straw clay is very heavy, and you have to mix it with stamping with the food, and this construction seems me more simple. And we had the opportunity, the occasion to build the first house in 1980. This was the client was interested and agreed in the first experience, and we started like it was written in the book. We have dry earth, we make a slip, we pour it over the straw, and then we remix this, and then we put it in the shuttering. And here you see our first wall. We are very happy. Here, my wife, here, younger years, and me, a little bit more on the head. And here, a very simple approach for walls, thicker walls, thinner walls, and also ceiling. And this is a very simple shuttering, and we had success from the beginning. This is light earth. If you look in detail, and if you cut light earth, you see very much spaces between the straw. It's air spaces, which gives a very good thermal insulation. That was my first reason to build a house: 30 centimeter light earth and nothing else, only plaster or cladding. This is a dining room with a ceiling in light earth, also the walls, and then the plaster with lime. Next project, 2 years later, we were asked to build a house low-cost house, yeah, and I proposed light earth, of course, and I showed the pictures from the first experiment, and the client agreed. So we started, and but this house is cladded with wood because we were angry about the adhesion of plaster on a new wooden structure because of the shrinkage of the wood. We anxious about, worried. You understand. This is a raw construction. A very simplified wooden construction, not comparable with conventional framework construction. You see very thin posts and no horizontal parts, and big spaces between the posts, not this narrow. And it's very wood scarcing, or wood economizing construction. And if you go in detail, but maybe it's okay, maybe here, these are the walls, walls in section. There are two here. You see that? No, pointing. Excuse me. No, it's not possible. Here you see a double column. Double column. This is a internal wall. It's thinner with some stakes in it. It's details. The children room, and in this house we made all with light earth. The external walls, internal walls, and also the ceiling. The ceilings. Here you see the ceiling. We have some shuttering, and on this we filled up heavy light earth. It's a contradiction, heavy light earth and light earth, you can say. I differentiate because you can put in this mixture very much clay or very less. And if you reach a very heavy mixture or very light. So to increase insulation, we want to have a light mixture because of the air spaces inside. So, but if you want heat storage, you want to be more heavy. In the heat storage is wanted in the internal walls and in the ceilings. The densities here, light is about 600 kilo. It's like wood, and heavy, it means density like water. Water is 1,000, and light, heavy light is also in this range. And in this project, after the first experience by hand, we tried to use a machine. To accelerate the mixing process to make the slip, and to pump it, to spray it directly in the room, also in the upper floor and in the roof. We transport by air pressure, by pump. We transport the heavy thing that's a slip vertical. And then we can spray it beside the wall. We will fill. Also, the shuttering we have a little bit improved. We just move the boards, and it's simplified. Oh, that's the result. It's okay. So after the first projects, I think 3 examples in the first edition of 83. I wrote this book, and it was very good sold. And there are many people which imitate, or they were enthusiastic, and they started to follow these ideas. And I estimate some thousands of applications in these times. Yeah, in the first, it was very famous, this book. It was the first book about Earth construction in Germany, yeah, with this light Earth. And later, here you'll see 1995, I added some chapter about combining the Earth, the light Earth, with insulation material, because we found out, or we were obliged to think about that, because the regulations on thermal insulation, yeah, were harder. We have to follow new values of U value. Yeah, we have to lower the U value, and we could not anymore build 30 centimeter light Earth, even with very light mixtures. So I added chapters with insulation layers. And later in 2016, and in these following, I introduced a new method of, I will show you, you will see later. You will see, it's too much. And for the book, I made researches, because it was not known, any properties was nothing known and nothing written, or okay. I made research in the literature to find values, to find informations about properties, and I collect them all, and I put them together to show what is known and what we have to research new. Yeah, yeah. And for instance, fire behavior of light Earth, it was nothing written. And so I went in the cave and I made some tests, and I compared it with another classified material, and I can say it's not easily inflammable, not easily flammable. Yeah, yeah, flammable. Okay, and thermal properties, the main chapter. I collected values in the literature. And I found these values of lambda. Yeah, it's main. And later I proposed these values for the official DIN norm. Yeah. This is 4108 in Germany, and they accept it, and now it's written in the official DIN norm. Not all these values, but the main part, yeah, up to, from 500 to I think to 2000 or something like that. And then water behavior and moisture behavior. Water is very interesting. Here I compared a block without fibers, and here a light Earth block, a very heavy one, to 1200. And you, if you put it in water, after 1 hour, you have this result. Yeah, this is the block without fibers, and this is a block with fibers. You see the great difference. You never put a house in water, okay, but it means also other behaviors from, for instance, for frost. What's happened if it frost? The one material will explode, yeah, and another will maintain his volume and his stability. Now, yeah, the next step in the history of earth building in Germany is, yeah, after these first 10 years of experimentation with light earth and other materials, earth builders has founded their firms, manufacturers. Yeah, they are now earth building products. Yeah. Yeah, before it was more or less a self-built thing, yeah, and now some firms started and other follows, and now we have a very wide spread market for earth building products, and I will show some of them. First of all, these are the blocks. Yeah, this is extruded blocks. It's just the same what you have in a brick factory, but it's not burnt. It's not burnt, and you can put it in walls or on ceilings. This is a light earth block. It's very good also for external walls, because the moisture and water behavior is very stable, and also but it means you have to plaster it, of course. Yeah, that's always the same, and a very light block or panel with hemp. It's you can make light earth not only with straw. You can all light fibers, reed, hemp, saw or wood granule, wood chips, yeah, and also the blocks are made of different mixtures. Panels, a big theme for the dry building, the dry made building. Yeah, you can. It's very advantageous. For instance, here, if you build here in this environment, you be internal walls. You use panels. You would use panels and dried materials to minimize the moisture which come on the side. Yeah, and it's prefabricated and very quick assembled. Mortars, yeah, mortars. This is the common method. You can transport sacks. It's sacks, yeah, bags and big bags, and it's dried material. Yeah, it's a little bit. Yeah, it's a question of drying energy. It's now they come to methods to dry it in greenhouses. Yeah, with solar energy. It's perfect. It's no fossil energy, or little, but it's minimized. But drying with fossil energy, it's hard. It's nearly conventional materials. We have not to forget this. Drying is also drying wood is a energy factor. Now some applications from these materials. We have these dry methods. We have the half timbered houses, which can be refilled with light earth blocks, and here machines are possible to mix slip or to spray plaster mortars on the wall, and so on. Now our projects. Oh yeah. Yeah. Okay. I show this is our summary of architecture. You don't see very much earth architecture here, but it's all earth architecture. Yeah, I can assure behind all these surfaces there is earth, and in walls and in ceilings, maybe also in the roof. And I will start with some renovations. Yeah. Yeah, this okay. Yeah. you see the facade is, as you see before, is light earth masonry, or if the panels are still partly intact, you can repair it with the same material. You take the old material, you mix it with water, and you fill up all this. You have not to replace all, only a little, yeah. And then yeah, you make a plaster, a straw clay plaster, or a new panel made with a traditional bottle and daub method. Yeah. The ceilings are in real earth reels. Maybe you know this method. Here you see from above, and then we insulated the external walls with some light earth from inside. Here's the construction, and we filled up. You see in the next project, it's nearby. Next project, also a half timbered house. This is the addition of light earth insulation from inside with earth panels, wood chip, light earth, and then the finishing with lime plaster. A new extension with elements of half timbered elements, and a completely dry earth building materials in the walls and in the ceilings. In the walls, this external wall, an additional layer on the inside, and in the internal walls, completely completely infill of extruded earth blocks. On the ceiling, also extruded earth blocks, because they are the most cheap materials, just not burnt bricks, and without mortar. It's very good because it's dry and very quick. Another renovation project is the Sandberghof. It's a Gothic house, and here we have the first time an internal insulation with some insulation material. It's with cellulose. Yeah? And this is a preparation, and at the end it looks like that. Yeah, yeah. Yeah, this is an internal layer. The ceilings are prepared like that. Old ceiling, old earth real ceiling. It's partly in good condition, but sometimes the beam or is damaged, and we have to repair. And this is a preparation, and then we make the earth reels on the table. This I want to show here. It was a demonstration from a French craftsman. It's a portion of hay. He took hay, is spread on the table and coated with slip. Yeah. A container is fashioned to define the required quantity of slip. This is the container. Yeah, the resulting light earth mix is rolled onto the riven wood stakes. Yeah, you don't mix a mixture before, you just mix it on the table. It's very quick, and this is a result. It's a very good method to make ceilings, but also walls. Yeah, external or internal walls. The next projects I would apply this method for all. It's very good. Next block, it's not a light earth project, it's made with blocks, extruded blocks, very cheap, in self-help. The whole house is self-built. And here we add the insulation from outside with sprayed on cellulose, and then a cladding. Cladding also self-made. Yeah, you see the structure inside and the wooden structure, and it's very warm house and very less energy to heat up. Yeah, it's very good. Next project is a new building with some earth filling in the external wall from the inside, and then outside 2 layers of reed boards, also prefabricated element. We had to build within half a year, from October to April in the winter time. It's possible because we used dry earth material. Yeah? Only the plaster was a problem, yeah? Because it has to dry. It was with artificial drying machines. It was possible. The internal walls, masonry of light earth, and then an undercoat earth plaster, and then the finish is lime plaster. And this is also earth architecture, but you would say it's earth architecture, okay? Now, the last project is in Darmstadt, also in our town. And here I want to show a new method of manually free applied light earth. It's not within shutter ring, yeah, it's just put on the wall as I found it in the old house, yeah, and I developed a little as I found. You can find it in Normandy. This is a torchis there, but with light earth, very much quantity of straw, and the density is about 1,000 kilo, yeah, and the insulation is from inside. Also prefabricated elements and some lattice, yeah, to put in the work. He worked from inside against a shuttering board, which is fixed provisionary, and to have a flat surface for the lime plaster outside. Yeah. The machine is very helpful. Also, we spray in the upper stories, yeah, with pump and air pressure. We mix it in the room. A little excursion also to Grenoble, where I made some courses and some demonstration experiment. This I experimented with students before we made this house to be on the side of security, of the safe side. Yeah, I wanted to know, is it possible? Goes it in a certain reasonable time? Yeah, is it hard? Is it good? It works or not? And there we tried this simple method of deeping methods, yeah. And the construction, as you see here, the outer layer of this light earth and the inner layer with thermal insulation. So these are the outer walls, and the inner walls we repeat what we made before in another project. We just stacked extruded bricks within in the wall, yeah, dry, without mortar, some some planks to fix it in the space, and so on. And this is a result. Also a very nice earth architecture. Yeah, everybody thinks, okay, what kind of red earth you have used? Yeah, but it's a normal lime plaster, yeah, painted with mineral red colored mineral paint. So now I have still 5 minutes. No, one project. It's also manual application. Yeah, also a self-building project, and the client worked. She worked herself and with her father, and some students helped. And I want to show just works. Doesn't work. Okay, it's okay. You can see the consistency of this material. It's like a plaster, and you can throw it on the wall. You onto 5 millimeters thickness only, because it's very, very smooth. And you flat it. Yeah, she fills up some. I cannot see the. I cannot accelerate. Okay, it's enough, huh? You see, it's. Yeah, now it's a chapter. maybe.
You can take 5 minutes more. Don't worry.
Okay, 5 minutes about a little bit natural climate control. You have seen the possibilities for Earth and insulations and so. And now I want to focus more on the general aspects, how to control the climate in the house, because it's not only the question of material, yeah, it's also the question of design and good design, window positions, and so on. And oh yeah, I start. The size and position of windows should respect the orientation to control the indoor climate. Yeah, you know that the sun in summer is very high and in winter very low, and you can use a low radiation in winter, and you have to be careful in the east and in the west. This is the ground. The east and west, it's dangerous because the radiations come really horizontal. And if you have openings in the east, the house is at noon, it's 30 degrees in it, because it's a solar collector to the east. And you have to know, you cannot realize every time in every situation, but the principle is clear. And also the principle is to avoid very glassed facades or openings, because every glass is very, it's a greenhouse effect possibility. You have, it's very hot in summer, and heat loss in winter is incredible. And so it must be artificially air conditioned. Yeah. The contrary is a high density flat dwelling, low rise development, for instance, in Chinese or Japanese courtyard houses. Today, the wood construction is very in fashioned. Yeah? Everybody want to build with wood, but the normal construction is very, very complicated. Yeah? We have light-weight insulation. We have vapor barrier. We have insulation levels. I don't know if you know that kind of construction. And now we propose a construction with a combination of heavier earth material together with insulation. Yeah, and we have, because of the moisture properties of earth and natural fiber material, we have the opportunity to simplify the construction, because we don't excuse me. I come later on the humid or moisture aspect of this simplicity of this construction. And the mass in the house, if you have much more mass in the house, we have the possibility to cool it during the night. We open the windows, and the night coolness ventilates through the house. It cools the heavy material in ceilings and internal walls. And during the day, the sun and the warmth, even by opened windows, is not enough to warm up the house very quick. And so you have comfortable temperatures during the whole day. Yeah. It's a big argument for earth building materials in wooden modern construction. And also the simplicity. This is a conventional, this is in Bregenzer Wald in Austria. And this is one of our projects. And you had here several layers and foils and glue adhesives and all these materials and rock wool as insulation. And here only earth and cellulose in this case, and a very good moisture behavior. Even here this problem, yeah, if here the conventional, if you have the the vapor barrier and there is a possible leak, then you have condensation, and then the wall cannot dry out because the rock wool is not capillary active. Yeah, it remains wet. Yeah, it becomes wet or humid, and it's not very good. In contrary, with wood and some natural fibers, you have a ventilation stop with a plaster. You have the vapor diffusion is given because all the materials are open for diffusion, and you have the permanent drying process by capillary properties. Yeah. Now this is an aspect. Yeah, you don't your thermal mass of the external wall is seldom needed on the inside. Insulation on the inside can be advantaged. Yeah, the normal argumentation is you have to put inside the external wall the mass. This is conventional. This is in the book, written in the book. But we say the contrary. Yeah, put the mass outside. You have advantage to gain solar energy in winter because it's gratis. Yeah, gratuitous. Yeah, it's gratuitous energy. The winter time, you have sun and also higher temperatures during the day. And you can use this heat gain. Why insulate against the sun in winter time? Yeah, and yeah, this is a plaidoyer for insulation inside. Also, I can heat up. Excuse me. You can heat up the internal insulation layer very quick. This makes it possible to heat up one room, room by room, or very quick. Yeah, you come in the room, you heat up with a stove or heating system, and in contrary, if you have the massive wall inside the external wall, it remains cold, and you need much more time to heat it up. Yeah. All these arguments speaks for an internal insulation and an external earth layer. Yeah, and this you can imagine if the sun is here, this is outside. If the sun is heating up the outside layer, then it warms up this material. It comes not through the wall to inside, but it warms up. And this decreases the temperature difference. And so you spare energy. And for each degree of spared energy, they say it's 6% saving energy. And all this we can make with wood and earth construction plus some insulation material. No, okay. Now I want to make a little bit the conclusion. This is my plaidoyer, building with wood, earth, and fibers. Yeah? we have simple constructions. The construction site is weather protected. It was the first aspect, working under covered roof. The wood is sparingly used for load bearing, while the earth is used for non-load bearing infill. This is a very old, very economic method, age-old, age-old. Also, the bamboo structure of Mr. Toki, it could be thought in these directions. As is used, simple constructions, more floor space by thin walls. That's very important. If you compare it with rammed earth walls, they are for itself 50 or 60 centimeter plus insulation material, and then you have 70 centimeter wall, and this is not possible in town areas because the ground is too expensive to make such sustainability. You have the ability to repair, modify, recycle, and reuse building materials. These are the consistencies of earth, hard or soft, fluid. All this you can make every time you can put water, and the material will dry and will be hard. Renewable resources as wood and plant fibers that means sustainability. Earth is as binder allows endless reuse, physical instead of chemical binding. Indoor climate and thermal comfort, thermal stability. The earth is good, has a good mass and can reduce the variations of temperature. Warm in winter, cool in summer. This is a result. Balanced mix of thermal insulation and thermal retention. A mixture from 1,000 kilo per cubic meter has both. It's insulating and also storing heat, and you can play with these properties. Mass is able to use solar heat gains. This is very important because this is gratuitous energy. Physical aspects, robust moisture protection, because of these capillary forces, good vapor conduction and capillary conduction, good fire resistance properties, good sound insulation, non-toxic materials, food grade. You can eat earth even to heal your stomach. You can buy it in a pharmacy. You buy some earth and it's very fine, and after one teaspoon, you have no problems with your stomach. Okay, that's the story, the whole story, wood and earth in collaboration with water and air. Air is very important to harden the material. Okay. Thank you. And if you, okay.
So thank you so much, Franz. I see there is. Okay, so feel free, of course, to ask questions. And everybody's also is also invited to ask questions to our lectures. So there are 3 questions at the moment, and one is coming. So these first questions are for Professor Toki. So I think the first question is from Luis. Would you please ask your question.
Could you hear me?
Yes, let me call for Professor Toki to turn on his.
So I would like to know.
Okay.
I would like to know what about the costs of the project, and because I saw that something like at the beginning you didn't have money for the project. I would like to know how have you found it to realize it, and how much it was how much it was expensive.
Of course,
Okay.
he is referring to the bamboo arc.
Yeah.
Okay, thank
sorry.
you for that. 予算とかどう予算を、確保したかっていうことについて聞きたいそうです。
予算ってなかなか難しいんですけど、まずこのプロジェクトやるときに全くお金なかったんですよね。で、それで、実際、竹を切るのは学生たちが行ってやったんですけど、その他いろいろ必要なものっていうのは、いろんな人から寄付してもらって、物でもらってやりましたね。で、
一
あと
一度ちょっと通訳してもよろしいでしょうか。
はいはい。
So for the project, we actually didn't have any money at that time, like literally zero and nothing. So what we did is to hope for donations from a lot of people, and to ask for the participation of the students. And let's hear the continuation. ではよろしくお願いします。
あと一番お金かかるのは多分現地での学生が生活するとか、あと物を運ぶとか、そういういろんな現地での作業にすごい多分お金かかるんですけど、それは被災者の人たちが一緒にやってくれできました。だからなかなかコストっていうのはすごく出しにくくて、地域の人の被災者と学生と外の協力してくれた人がみんなで作り上げたっていうことで、なかなか普通のプロジェクトみたいにコストがいくらっていうのは出しにくかったかなという、出せなかったプロジェクトですね。
Okay, so to sum it up, the most expensive part of the project itself was the cost of livelihood for the students on the site, and for the transportation of the material and the tools. But the difficult part is that we couldn't make that as a number, because most of them is a part of donation, and how we and the local community kind of collaborate together. And so we can't really put a number on the expense of this project. So I guess that's the one unique part of the project itself. But yeah, it's hard to put a number on the total expense of the project.
あと嬉しかったのは、これをやろうというふうに思ったら、いろんな人がいろんな形で協力してくれて、だからみんなの協力がないともちろんできなかったプロジェクトですよね。
So the one more part of the project is when Professor Toki talked to the local community. So, for example, let's do this and let's do that. They just, okay, what do you need? And if I have it, I'll give it to kind of relationship. So that was one of the special points of this project also. I hope that could be an answer, but yes, it's kind of hard for me also to put a number on the expense, on the total of the project itself.
Thank you so much. There is one more question from Ricardo, please.
Hi. Of course, the question is about the bamboo arch. I would like to question about the time of the project and how much time you spend on the research for the test for the bamboo arch.
So from the research until the completion.
And the time of the construction site, how much you spend on how much time you spend on the construction site.
Okay, let me just so ですね、研究と工事のスケジュールについてなんですけども、研究にどれぐらい時間かかったかのと、あと工事自体がどれぐらいかかったのについて聞きたいそうです。
時間はすごく限られて短かったですよね。で、もともと竹の研究は基礎的な研究をやっていたので、それを活かせるところはあったんですけど、このプロジェクトをやろうと決めてから完成するまで5ヶ月ですか。さっきそこまでして。
Okay, so it's the project itself, the schedule for the project itself is very, very limited at the time itself. Well, it is true that from the start, we have already been doing the bamboo research itself, but from the research until the completion, we only had 5 months. And let's hear the continuation.
大地震が起こったのが3月で、現地を最初に訪れたのが4月。で、その後、これをやろうと決めたのが5月だったんですね。で、作るのは9月には完成したかった。というのは、夏休みが終わるのが9月なので、それまでに完成させないと、また半年延びてしまうか。9月には完成させで、ということで、さっき言った研究リサーチとかデザインとか、申請とか、すべて含めて、3ヶ月、4ヶ月か。で、工事は、1ヶ月でやりました。だからすごい突貫工事だったけど、逆に期間が短いからみんなすごい集中力で成し遂げたって、そういう感じですね。
Okay, so the disaster itself happened on March, and Professor Toki went to the site at April, and the research and the preparation started at May. And the project, we had to finish it before September because the summer vacation is over in September, and we only have students to work with. So, and for the preparation and the research and all that, and for the permission, we only had 3 months, which is May, June, and July. And for the construction itself, we only had 1 month for before the deadline. So it was very limited schedule. And this is the schedule that Professor Toki has shared us. And we had to finish it before 11th of September. And
これ見えてる？
はい、見えてます。
で、これが設計始めるときに立てた全体の工程で、この一つの単位が1週間なんですね。で、だから基本設計2週間、実施設計2週間、施工図書いて、でその間に現地で竹の伐採とか整地とかをして、で、右の方が工事で、この時は3週間で、工事を終えると。そんな工程です。
So this is the rough schedule of the project. We had to do the basic design and the detail and detail design in 3 weeks, and for the construction itself is 3 weeks. So yeah, once more, it was we only have this much time to do it, the construction and the design and the research.
Okay, thank you very much.
Okay, thank you.
So thank you so much. There is one more question for you, Professor Toki. It is actually a question by 2 girls. So Natalia and also Janet. Please, Janet, come because your questions are very close to each other. So I think you can ask your question together. Oh,
hi. Actually,
louder, please.
I'm sorry. Oh, hi. My question was about the durability of the material, because I don't know if I understand it well. You said something about the natural bamboo that would not last a very long time. So I would like to know, like, how long can it last, or if there's something that could make that can be made for, like, to increase the durability, if it could be like a permanent structure or not.
Yeah, if it was only used for periodic constructions to disassemble that later on. So I wanted to know if we can preserve this without using any chemical effects or products, and without like always having to keep an eye on the structure and the maintenance.
Okay. 耐久性についての質問なんですけれども、どれぐらい持つっていうのは一つの質問です。で、次の質問が化学製品なしで、耐久性を上げるのは何かしらの方法あるんですかっていう2点の質問です。
で自然な竹でも耐久性を上げようとすれば放射とかいろいろ化学処理するっていうやり方は、これはインドネシアでとか、東南アジアで盛んで、そうすれば一応室内だったら50年は持つと言われてます。まずそこまでいく。
So, firstly, if you want to make bamboo last longer using chemicals, you can use borax acid, and it's mainly used in Southeastern Asia, and it could last up till 50 years. And that is the case using chemical appliances. And let him let's hear the continuation.
今研究しているのは、還流って言って、中の水分と養分を抜いて炭化させてしまう。それは化学繊維なしで、耐久性を高めるというやり方で、木ではよくやられてるんですけど、竹ではまだそういう実績ないんですけど、その木の技術を竹に応用して、いわゆる薬使わずに耐久性を高めるという研究を始めているところです。
Okay, and the next part is there's another way to make bamboo last longer, and which is to wait a minute. Okay, so to carbonize the bamboo by using heat and all that and pressure to get the watery parts of the bamboo out, and so it also makes the bamboo last longer, which is what we're in the process of research right now. So that's two ways of making the bamboo last longer. And for the natural bamboo, how long it lasts, let's hear the continuation. あとはですね、自然な竹どれぐらい持つかっていうことについて。
今日紹介した建物は、何も未処理で何もせずに7年半持ったんですけど、だいたい4年ぐらいで少しずつ折れるものが出てきて、でそれを見ると虫が食ってるんですよね。だからやっぱ防虫処理しないと、やっぱり4年5年くらい経つと虫が食い出して、竹の会社の建物はそうやって被害を受けながらも、そこは直しながら、全体で持たしながら7年半持たしたんですけど、やっぱり4年ぐらいでも虫が食い出すのかなって。で、これは一般的に世の中で言われていることとほぼ合ってるかなという感じですね。
Okay, so for how long natural bamboo lasts, for this project itself in Bamboo's Arc, it's completely natural bamboo, and we only discovered the damaged part after 4 years or so, and the damage was mainly because of insect attacks. So if you can do if you can use chemicals to prevent that, of course it would last longer, but commonly it's from 4 years, from 3 until 5 years, up to 5 years if it's complete natural bamboo. So yeah, I guess.
で、あとも伝統的に昔からやられているのは、アジアでは水の中につけて6ヶ月ぐらい置いておくというやり方があったり、日本では油抜きって言って炙ってその油分を抜くと、そういうやり方も伝統的にやられています。
So another way to make bamboo last longer, especially from insects, is to take out the sugary nutrients in a way that you can sink the bamboo in the water for 6 months or more, and that's pretty common in Asia. And the other way is to use fire and to heat it up using torch and all that, and this one is pretty common in Japan. So, but yeah, by using fire you can damage the bamboo itself, so it's not quite recommended to use it for structural.
さっきの建物はそれをするだけの時間もお金もなかったので、 そのまま切った竹をそのまま使ってました。
And for this project, we had no time nor money to do the preparation, so we just cut the bamboo and just used them all. So I hope that's enough for an answer.
Yes, thank you.
Thank you.
Yeah, I guess it should also be added that, as you explained, the bamboo was harvested in the wrong season. It is better to harvest the bamboo in the winter time
Yes.
when the sap content is lower. And arguably, this might have increased the durability of the material, even if untreated, even if without any kind of treatment. So thank you very much. There are now a few questions for architect Volhard. Please.
Okay. Hello. Okay. So the question is about the use of the clay and wood, like a dry material and a moist material. I wanted to know if at any point in your research or development process, was there an issue between the moisture in the clay and the timber structure? Does this moisture or water content affect the timber in any way? Or
thank you. Thank you for the question. Maybe you think that earth is a very humid material and it will attack the wood. Maybe this is, you presume, but the contrary is a fact. Yeah, earth is very, very dry, normally 3%, and wood is 16, something like that. And the experience is that all these old structures are very well in good state. Yeah, if they were protected by a roof. If you maintain the panel dry, yeah, you protect it, it's everlasting. We can say hundreds of years. You saw the Roman thing. You saw this. Remember the straw which I washed out. Yeah, it's intact. You can, even the tension is still functioning of the straw fibers. Yeah, it's incredible. Yeah, and we say okay, the wood, the clay neighboring wood parts has a drainage qualities. Yeah, and therefore it's good together with wood. Very good. Yeah, maybe it's better than rock wool, because if rock wool remains wet, it's very bad. Huh? Yeah, and it dries not. It doesn't dry naturally, because there is no capillary activity, and clay is the capillary material gaze par excellence. Yeah, okay.
No, please. There is one more question, Luciana.
Good morning, and thank you for your presentation. First, you already explained a bit about this, but I would like to know also about the durability of the materials. First, if there is a material deterioration, and if yes, how high are the maintenance needs of the projects?
Yeah, maybe the same answer. If you maintain the building dry, and you maintain the earth, and this earth mixtures also permanent. Yeah, we have never heard about deteriorations or some changements. Yeah, you have to respect the same measures to protect the construction dry as wood construction. Yeah, wood you have to protect. Yeah, a permanent humidity for wood is dead, is the end of life. Yeah, if you some months are enough to destroy, to rot wood. If you have some corner every day is there is some water from roof, or yeah, then it goes very quickly. Maybe this is an advantage. In France, you see everywhere buildings where the people is not interested to maintain them, and after some years you see amount of rotten material, and after 200 years maybe there's nothing, there's forest or nature. But okay, this is an ideal argumentation. Yeah, yeah, but normally it's no problem to maintain. And you have the plaster, you have a cladding to protect the facade, and this is necessary also for wood. Yeah.
Of course, the capillary rise from the
yeah, this is normal building technique. Yeah, to make the vapor, the barrier against rising moisture. Yeah, sure, but above 30 centimeter above the ground, you can build with wood, earth, and all the things. But lower, okay, then you have to use a solid material. You cannot make a cave with earth. Yeah, with timber. No, it's not usual.
Thank you so much, everybody, for having been together with us this morning. I think it has been a really dense morning, packed with experience, packed with knowledge, a lot of information, which certainly will benefit both the students who were present today here, and those who will possibly have a look at the recorded file of this very interesting seminar. So thanks once again to Professor Toki for having been with us and shared his knowledge with us. Thanks to Vincent for the nice translation, and thanks to Franz Volhard for having been here with us. He came express from Darmstadt to share his knowledge as well. So I hope this was as exciting and fruitful for you as it was for me. I really hope that we can go on cooperating and exchanging knowledge and experience. Thank you so much.